Hello doctor, my name is Srivani Murugan from section 10. Going to present about my project 2. The title of this project is Prevalence of Overweight and Obesity among secondary school students. So the purpose of this project is to investigate the factor of overweight and obesity among students. The dataset obtained from the prevalence of overweight and obesity and its associated factors among secondary school students in semi-urban area in Malaysia. So there are many factors, but I only choose 3 factors, which are physical activities, gender, and age. So I conduct each of the tests with different factors. So first is hypothesis testing using 2 sample tests. The variable selected for this testing is gender and number of students with BMI status. The obese. The claim is that the overweight and obese was higher among males as compared to the females. Proportion 1 is male and P2 is female. A simple random sample data are used to figure out the Z-score of this project. The Z value of the 2 proportion calculated using RStudio. I used right tail test. So the P value is the area to the right of the test statistic equal to 3.99. Since the P value is less than critical value, the Z value fell in the critical region and we can reject the null hypothesis. And there is a sufficient evidence to reject the null hypothesis. Next is correlation. The variables selected for these correlations are age and number of students with BMI status is obese. In the correlation test, analyze the relationship between the age of students and number of students with BMI status obese. The correlation R is calculated using the Pearson's techniques since the data being tested is a ratio type data. The independent variable X is the age and the dependent variable Y is the number of students with obese. The result from RStudio showed the dots from negative slope means it is a negative correlation. The 2 variables are then tested to see evidence of linear relationship between the variable at 0.05 level of significance. Seeing that P value bigger than critical region, the test statistic is not failed in the critical region and we fail to reject the hypothesis. There is no sufficient evidence to linear relationship between the both variables. Next is regression. The same variable of correlation used to test the regression. The regression of 2 variables are analyzed to predict the relationship of the variables. The graph showed a linearly decreasing relationship. The relationship is weaker linear between the variables. This is a negative correlation because the number of students decrease when the age is increased. From the output, the estimated regression line equation is equal to 421.762 minus 20.857x. The intercept is 421.96 and the V1 is negative 20.587, tells us that the average number of students with obese decreased by negative 20.587 on average for each increment on the age of students. The p-value for intercept is 0.0241 and for the predict is 0.0630. The t-statistic test fail the region between the p-value. Between the p-value, so we fail to reject the null hypothesis, which means that there is no sufficient association between age of students and the number of students with obese. The standard error and confidence interval of model shows where the lower limits of P1 is negative 43.53 and the upper limit is 1.82. That is a 95% of chance that the interval between negative 43.53 to 1.82 will contain the true value of P1, which is negative 20.586. In this study, RSE equal to 34.16, meaning that the observed number of students with obese divide from the true regression line by approximately 34.16 units in average. The percentage of error can conclude equal to 28.6. The variable selected for chi-square test of independent is physical activities and BMI status. Chi-square test of independent is used to test whether the relationship is existing between physical activities and BMI status. The claim that at 0.05 significant level, the physical activities is independent to the BMI status. So, the n square equal to 4.7 in the degree of freedom is equal to 1. The critical region could be found in the test distribution table with degree of freedom equal to 1 and significant level of 0.05. The critical value are found to be approximately 3.841 since the S square bigger than the critical value. The test statistic x square fall within the critical region, therefore we reject the null hypothesis. There is insufficient evidence to show that the physical activities is independent to the BMI status. For the conclusion, the students are future of our country, and thus it is unsatisfactory to put them at the risk for obesity and overweight. By recommended healthy diets and exercises, the childhood obesity throughout the country can be ended. Thank you, doctor. That's all from me.